Sathyabama Institute of Science and Technology.
Hello everyone, I am Dr. N. Srinivasan from Computer Science Department, Sathyabama Institute of Science and Technology. Today we are going to see about soft computing techniques. It's absolutely a case study approach. So soft computing is a branch of artificial intelligence. It provides adequate solutions to the complex problems in which the problems are not solved by the classical methods. So what are the constituents of soft computing? The constituents of soft computing are fuzzy logic, neural network and genetic algorithm. The fuzzy logic is mainly used for reasoning, neural network is used for learning process, and whereas the genetic algorithm is used for searching and optimization. So what is a fuzzy logic? We all know about the binary logic. The binary logic represents a 0 or 1, or it may be a true or false, whereas the fuzzy logic here represents the range of values from 0 to 1. If you see this example, is it cold is the variable, and you see the answer very less, which is 0.1, and little, which is 0.25, and very much, which is 0.9. So we have a range of values from 0 to 1. And coming to the fuzzy system, a fuzzy system is a one in which we have the input which is in the form of a fuzzifier. Fuzzifier means which will convert the crisp inputs into fuzzy inputs. Then we are having the fuzzy rules. So that fuzzy rules are validated by the inference engine. There is a block called a defuzzifier which will convert the fuzzy variables into the crisp values. Now we have taken the case study for the stock price prediction, right? In case of stock price prediction, the data are collected from a blog or from the historical websites or from national stock exchange websites. That is called as the event data, right? Then we have the feature processing. The particular features of the stock can be accessed as a parameter. Then we have the fuzzifier. Then based upon the knowledge base is nothing but the way in which the values are going to change, right? So that is the knowledge base in which we are going to write the fuzzy rules. Then we have the inference engine which is used for the matching the rules, and it will do the conversions. So fuzzy logics are mainly used to find the stock price. Next, the second component of the soft computing is the neural network. So this neural network is to train the network, right? So that is mainly of the learning and testing process. So each neural network consists of many layers. They have the input layer, hidden layer and the output layer. So the input layer is the values that we are going to give. The hidden layer is nothing but the knowledge, right? The output layer is what we have extracted from the network. So this is the block diagram of the a simple artificial neural network. So we have the inputs from x1 to xm, and we have the weights w1 to wm, and this sigma is nothing but a combinator, and we have an activation function, and at last we have the outputs. And see this sigma, what we call it as a combination, which is nothing but the addition of bias and weights multiplied by the inputs. So this output equal to activation. When the output is equal to activation, if it is a linear function. Suppose if it is a hyperbolic tangent function, then that activation is nothing but the tan component of the combination. Next, this one is again a case study of the stock price prediction using neural network. So we have the input layer, and we have the hidden layer here, and we have the output layer, right? So here the data for the particular day. So for example, if it is a real time stock, we have the open price, close price, day high, day low. So that is the particular day, and this one is the number of hidden layers. Hidden layers are nothing but the accessible parameters, and the output layer which will gives you the transaction plus 1, that is the next day stock price. Now come to the performance measures in the neural network. Accuracy. So how many times the model was correct, that is called as accuracy. Precision, how many times the model is good for a specific category, that is called as precision. And recall, how many times the model is able to detect a specific category. So these three are the important performance measures in the neural network. Next, the third component in the soft computing is the genetic algorithm. This genetic algorithm consists of similar terms, what we call it as population, chromosome, gene, crossover, mutation, right? First we will see about the population. So, population is nothing but a subset of all the possible solutions of the given problem. That is what we termed as a population in genetic algorithm. Chromosome is nothing but a one such solution. A gene is nothing but an element position of a chromosome. Now, fitness function. So, fitness function is the important criteria in genetic algorithm. So, this fitness function is a function that takes the solution as input and produces the suitability of the solution as the output. So, the input is the solution, the output is the fine tune of the solution. Next, crossover. So, again it is a genetic operator which is used to vary the chromosomes. So that it will move to the next generation. Next, mutation. Mutation nothing but changing the particular bit of the chromosome. And see this. So, this is the block diagram of the genetic algorithm process. Start, it will generate the initial population. Then we have the parameters settings, fitness function evaluation. So, the important criteria. Then we have applying the crossover and mutation. Then we are check for the termination condition. If the condition is satisfied, then it comes to an end, otherwise it will be put up on a loop. Now, see this a soft computing model which consists of a fuzzy logic, a neural network and a genetic algorithm, all these three techniques. So, the first part, the first block gives you about the fuzzy logic, the middle one will gives you about the neural network and the last one will gives you about the genetic algorithm. As I said earlier, the first part we have the fuzzy variables and we have the membership functions that comes under the variable selection. The second part is mainly of training the network. Here we have used the back propagation method, and the third one is to improve the results. So, we are using the genetic algorithm for optimization, right, and at last we are going to store the results. The applications of soft computing. Soft computing finds various applications in variety of fields such as handwriting recognition, image processing. Image processing is widely used for satellite communications. Then systems and manufacturing, particularly mechanical systems, right, the dimensions of the systems are very important, as well as it will find out any defects in the systems. Then decision support system, particularly in the case of transportation. Then power system to calculate the power loss. Then fuzzy logic control applications. Then machine learning applications which is used in a variety of fields. Then we have a speech and vision recognition. Then we have system process control and other applications. So, this soft computing is a branch of artificial intelligence which finds plenty of applications for all the social and economical applications. So, thank you so much for joining.